Okay, today we're going to continue our coverage of section 4.1, algebraic expressions and formulas, and we're going to finish up this section of the chapter, which means that we are going to finish our objectives. So yesterday we talked about evaluating algebraic expressions. Today we're going to use mathematical models. A mathematical model is basically a fancy word for a word problem. So I'll have a few word problems today. Then we're going to review the vocabulary of algebraic expressions, and we're going to talk about simplifying algebraic expressions with properties that we have discussed earlier. So let's go review some vocab before we get started. Remember that an equation is formed when an equal sign is placed between two algebraic expressions. A formula is an equation that uses letters to express a relationship between two or more variables. A formula that you might be familiar with: distance equals rate times time. That's a very common formula that everybody should be familiar with. And then, of course, we have mathematical modeling that I just mentioned. It's the process of finding formulas to describe real world phenomena. So it's basically word problems. So that's a good place to start. So let's talk about, we have a bar graph below that shows the estimated number of calories per day needed to maintain energy balance for various gender and age groups for moderately active lifestyles. Okay, the mathematical model F equals negative 66x squared plus 526x plus 1030 describes the number of calories needed per day by women in age group X with moderately active lifestyles. So what they want us to find according to the model. Now, but they're saying according to the model. That doesn't mean go read the chart and whatever the numbers are. According to the model, and this is our mathematical model, this equation. How many calories per day are needed by women between the ages of 19 and 30 inclusive with this lifestyle? So you're going to go down and figure out which age range they're asking us, 19 to 30. That's this age range, which is group 4. And in this model, group X, whatever you group number, that's what you're going to plug in for X. So that's what we're going to do on this page. 19 to 30 was designated as group 4. So we substitute 4 in for X into the model. And it looks like that. We talked about that earlier, yesterday. So we plug in 4 everywhere we see an X. We do our exponents first. So 4 squared is 16. We carry everything else down. And then we do our multiplication. And then we add. So the formula indicates that there are 2,078 calories that are needed per day by women in the 19 to 30 age range with a moderately active lifestyle. Okay? So you'll get to practice some of those. Let's go talk about some vocabulary of algebraic expressions. First off, very important, is the word term. And a term refers to any part of an algebraic expression that is separated by addition, of course, or subtraction, because subtraction could be written as addition. In this expression, 7x minus 9y minus 3 has 3 terms because there are 3 terms that are separated by an addition sign. So I want you to write the number 3 here and circle it to show me that you are listening. All right, the next part we have is the numerical part of a term is referred to as the coefficient. So when you look at 7x, 7 is the coefficient. In this term, negative 9 is the coefficient. And in the last term, negative 3, because each of those is the number. Okay, now when you have a term that is just a number and has no variable, it's called a constant or a constant term. And terms that have the exact same variables, that means they have the same variables with the exact same exponents on it, those are called like terms. Now, in each of your term, the parts of each term that are multiplied together are, of course, called the factors. We've talked about that before, that factors are numbers that are multiplied together. Okay, so we need to review our properties. So we have the commutative property of addition. Commutative means I change the order commuting back and forth of what I'm adding. So a plus b equals b plus a, or this would be an example with algebraic terms in it. Okay, if it says the commutative property of multiplication, that means I'm going to change the order of what I'm multiplying. A times b equals b times a, which is why it doesn't matter which way you write this, 6x or x times 6, they mean the same thing, but we generally write the number first. The associative property, remember, is who do you hang out with? Who do you group with? Who is in your group of friends? So that's our grouping symbols of parentheses. And the order A, B, C did not change from one side to the other, but what I put inside the grouping symbols changed. And I'm adding all of these terms. That's why it's the associative property of addition. And they're explaining to you why, even though these two are grouped together, I can change it and group those two together and then simplify that algebraic expression. Of course, if I was not adding but multiplying, it would look like this, which is how we get that negative 2 times 3x is equal to negative 2 times 3 and then x, or negative 6x. So these properties, you don't realize you're using them, but you are whenever you simplify algebraic expressions. And the monster of all is the distributive property, where we make sure we get salt over all the chips in the bowl. You have to remember that multiplication distributes over addition and subtraction, and you have to distribute it to every item inside the parentheses. And there are your numerical examples to look at. Okay, so the next thing you'll do is we're using those properties to simplify algebraic expressions. So if I have an expression that says 5 times the quantity of 3x minus 7 minus 6x, I have to remember to use the distributive property 5 times 3x and 5 times 7. And we just carry the sign down with it. So we use our distributive property first, and then we're going to multiply. Oh dear, hit the wrong thing. Then we're going to multiply. And then we're going to we're going to group our like terms is what we're going to do. And so we got the 15 minus 6x. And then we simplify what's inside there by combining our like terms. And that's as far as we can go because there's no variable here. This is your constant, and this has a variable. Those cannot be combined. Okay? And the last example that we have is this expression, and you need to remember again to distribute. So whenever you have something outside your parentheses, you're going to distribute it to everything inside. So when I do that, oops, I don't know what happened there. We got the 6 times the 2x, 6 times 4x, so you can see it being distributed to everything in the parentheses. 10 times 4x squared, 10 times 3x. Then you're going to multiply each of those, and then you're going to find your like terms, which in this case are going to be the two with the squareds on them. So we have 12x squared and 40x squared together, and then we have 24x and 30x, and that simplifies to 54x squared plus 52x squared, plus 54x. So you need to practice these, and if you have any questions, please come up and see me.